Hey peeps, it's Aldo from Zero to Mastery, and in today's tutorial we're diving into strings and runes in Go. Now this isn't just any tutorial, it's part of Jayson Lennon's complete Go programming bootcamp course available on Zero to Mastery. So if you want to learn Go completely from scratch, click the link in the top right hand corner or check out the description below for the full course. Alright, that's it from me. Let me hand it over to Jayson. Enjoy!
In this video, I'll be discussing strings and runes, including text encoding, about runes, and about strings. First, let's talk about text encoding. Textual data in Go uses UTF-8 encoding. And encoding is a way to represent thousands of different symbols using code pages. Code pages are tables which use the first few bytes of data to determine which page to use. And each symbol in the code page is called a code point. Let's take a look at an example code page. If we look at the lowercase d here, we'll see that we're at code point 1 and 3. So to create a d, it actually takes 2 bytes in this case. We have to have a 1 and a 3. Down here at the bottom, if we want to create this Japanese character, we'll have to use 4f followed by 1. So this particular character here takes 3 bytes, 4, f, and 1. In Go, when we work with strings and runes, we're actually working with individual bytes, not letters themselves. So it's important to understand that letters can consume more than 1 byte. Now let's talk about runes. Text in Go is represented using the rune type. This is similar to char in many other programming languages, like C. Rune is just an alias for int32, which is just a 32-bit integer. Since runes are just an alias for int32, you're actually just working with numbers whenever you're working with a rune. This includes when you try to print out messages using runes. In order to print the actual character it represents, you'll have to use a special formatting operation, which we'll cover later. Runes can represent any symbol, and this includes letters, numbers, and emoji. Let's take a look at how runes are represented in memory. Here we have 2 green rectangles, which represent int32s. Each one of these blocks are 8 bits, which adds up to 32 bits. We have here on the bottom the number of bytes. So here's the first byte, second byte, third byte, and fourth byte of a 32-bit integer. To represent the capital letter Q, we have to have 51 in our position 1 byte. To represent the zigzag, we have to have this combination of bytes in these specific locations in order to get a zigzag. The reason this is important is because the letter Q is only 1 byte, the zigzag is 3 bytes, but if we were to try to iterate over each letter, we'll actually be iterating over each one of these bytes instead of the entire letter itself. Once we get to the section on looping, we'll be covering how to iterate over the actual representations instead of the byte values. Now that we've covered runes, let's take a look at strings. A string is a data type for storing multiple runes, and strings are just an array of bytes and a string length. There is no null termination with a Go string like you have in C. When iterating a string, iteration occurs over bytes, and bytes are not symbols, as we previously seen. Special iteration techniques are required to retrieve these runes and symbols, which we'll be covering in a later lecture. Let's take a look at how strings are represented in memory. On the left, we have some runes. We have a Bitcoin, the number 3, a right arrow, and a cent sign. Each one of these runes has a specific bit length. On the right, we have a string, which is just a combination of all of these runes. This particular string is 9 bytes long. We have 3 bytes from the Bitcoin, 1 byte from the 3, 3 bytes from the arrow, and 2 bytes from the cent sign. So if we were to iterate through the string, we'd be going 1 byte at a time. And if you split these bytes in half, then you won't have a Bitcoin anymore, you'll have some different symbol. Recall that runes are just numbers, and since a string is composed of runes, a string is just more numbers put together. Let's take a look at how to create some runes. So to create runes in code, you surround the rune that you want to make with single quotes. So here we're creating a rune A, rune R, and rune 7. You'll see also that we can create an omega symbol, a rupee symbol, and a 1/2 symbol. Instead of using single quotes like we're using here, we're using backticks. The backtick symbol is next to the number 1 on your keyboard, and you'll need to use it whenever you're trying to type a symbol that isn't present on your keyboard. So basically anything that's not A through Z, 1 through 9, and 0, and any of these symbols such as the @sign, $sign, %sign, those are all okay to use the single quotes. However, everything else you'll need to use backticks. If you aren't sure if you need to use single quotes or backticks, you can just always use backticks and you'll get the symbol that you're looking for. There is one exception to this, and that is escape symbols. Escape symbols start with a backslash. So \n will turn into a new line. And we'll see here in the string shortly that they'll be highlighted in your editor, so you'll know if you're working with an escape sequence. To create strings, we'll use double quotes. So here we have amount is 22 euros, followed by an escape sequence, which is \newline. So this string will have a new line at the end. And we can also put a single letter within a string using double quotes. So here we have the letter K, and that's a string instead of a rune. Even though we could just make this a rune, since it's a single letter, since we want a string in this case, we can use double quotes, and that's fine. Lastly, we have the raw literal, and a raw literal is surrounded by backticks. You'll want to use raw literals whenever you're working with strings that have single quotes in them or double quotes. The reason you want to use these backticks is if you have double quotes within your string. Since the double quote is used to create strings, if you want to include them in your string, you either have to escape them with a backslash, or you can just use a raw literal. I recommend using a raw literal since it's much easier to read the string without a bunch of backslashes. One thing to take note with the raw literal is everything you type in here is going to come out as is. That includes this escape sequence here. Notice how this one is highlighted in purple, and this one is the same color as a string. That's because when we type a raw literal, it's going to type everything literally as you see it. So we're going to get a backslash and an N in the output instead of a new line. So here we have a new line because we're just using double quotes. And here we have a \n because we're using raw literals. And it doesn't apply any processing to your string, so it's just going to come out however you type it. Let's recap. Text in Go is encoded using UTF-8. The rune type can represent any individual symbol, and rune is just an alias for integer 32, and they are created using single quotes. The string type contains a series of symbols as bytes. Strings are not null terminated, and they are created using double quotes. Raw literals are created using backticks, and whenever you type something in a raw literal, it'll come out exactly as typed.
And there you have it, folks. A big shout out to Jayson for guiding us through this lesson. If this tutorial has you hungry for more, don't even worry because there's a whole lot more to learn in his complete Go Programming Bootcamp course, linked in the top right hand corner and in the description down below. Also, don't forget to like, subscribe, and hit that notification bell so you never miss out on future tutorials from Jayson and other expert Zero to Mastery instructors. Alright, that's it from me. Keep on learning, and I'll catch you in the next video.